we'll build the 3D geometry as a components stack, ideal for this kind of mesh. Let's generate the base layer with Bridge Generator. As you can see, everything is ready for the 2D simulation: section elements, materials, and boundary conditions. Now we'll create the concrete layer of the floor. We can use another component as a guide. We simply need a rectangle representing the concrete. Now we just need to assign the concrete material to it. We also want some ceramic tiles over the concrete. Let's duplicate the base layer. Tiles will be placed only on the internal side, so we also need the wall geometry. Let's generate the required geometry. And fill it with the proper material. Now we generate the 3D mesh as a stack of components. First, we add the bottom wall and set its height. Now it's time for the concrete layer. And the one with ceramic tiles on it. We want it only 20 mm tall. The last layer is the top part of the wall. Like with 2D simulations, we need to assign boundary conditions to the model. Remember that when using the first assign tool, you can set coplanar triangles with a double click. We want to check condensation in critical conditions, so we change the default internal humidity. Everything is set to perform basic flow analysis and condensation checks. The wall is well insulated, but not the floor. Expect heat loss on the horizontal layers. Flow and flow direction visualizations can be really useful to spot critical surfaces. It's clear that a lot of heat is lost through the corners. We can also see that there's mold risk. Now it's time to compute chi. We need some information contained in the 2D simulations. We need to take note of the wall's nominal transmittance. 0.2653 watts per square meter Kelvin, and psi minus 0.05341 watts per meter Kelvin. We'll use these values to create 3D section elements. Area section elements will represent the external walls. They will have the nominal U value we just saw in the 2D simulation. We now need a linear section element representing the linear thermal transmittance along the height of the model. It will have the psi value of the 2D simulation. We also need the floor's linear thermal transmittance. We need to generate the 2D vertical section of the bridge. First, we generate its construction lines. There's just one 2D section element. We need to make sure that the width line of the element intersects the wall only. Let's assign all the materials. Now, we need the boundary conditions. Like in 3D, we can set collinear segments with a double click. We need the psi value from this 2D simulation. It's 0.21637 watts per meter Kelvin. We can use this value to generate two linear section elements along the external sides of the wall. We're now ready to get the chi value representing the 3D thermal bridge.